Chemical bonding, part 2. We talked about molecular shapes and a couple of more sophisticated bond theories, steps above Lewis theory. So this is kind of interesting. I'm not going to test you on this, but I think it helps us to understand why shapes of molecules might be important. The taste of something and how many calories it contains are independent of each other. Caloric content, we've studied that. That's energy released when something is burned or metabolized. So it's the amount of heat released when food is metabolized. Okay, this is sucrose. When sucrose is metabolized in your body, it releases 5,644 kilojoules per mole of sucrose. The taste, when we eat table sugar, it tastes sweet to us. That has to do with the shape of the molecule and the charge distribution on the molecule and how that interacts with the taste cells on your tongue. It has nothing to do with how many calories it generates when your body metabolizes it. So enter artificial sweeteners, because people want to eat more without getting fat, right? We like sugar. We like the taste of sugar. So artificial sweeteners fit into the same receptors on your tongue and tell your brain that this food is sweet. And yet when your body metabolizes them, it gets very little energy out of them. So you can get your sweet taste without having to deal with as many calories. In order to design things like this, we have to have an understanding of how and why molecules are the shapes that they are. And so that's what we'll be talking about in this chapter.